Hi everyone, in this video we are going to discuss about power system production module 4 for module 4. So in that arc voltage and arc interruption. So first we will see the what is meant by arc voltage. So arc voltage means the voltage drop across arc. The voltage drop across the arc is called arc voltage. So whenever fault occurs, arc will be produced inside the circuit breaker. The voltage across the arc is known as arc voltage. So this arc path, the arc path is purely resistive. So the voltage and current, the phase difference, if you observe, that will be equal to 0. The both will be in phase with each other. The arc voltage and current both are in phase. Then the angle between these two, arc voltage and arc current, is equal to 0. So that's what we can say. Arc path is purely resistive. Okay. So next one, the magnitude of the arc voltage is very low. So very low, amounting to only a few percent of the rated voltage. So we can see this one, you can see in this waveform arc voltage magnitude and short circuit current magnitude. Short circuit current magnitude is more than arc voltage magnitude, right? So short circuit voltage magnitude is more than the arc voltage, but if you see the phase difference, both are in same phase. So both you can call it as a in phase with each other, but magnitude is having some difference. So arc voltage magnitude is less than the short circuit current magnitude. So typically it may be 3% of the rated voltage, 3% of the rated voltage. So the arc voltage magnitude is maybe 3% of rated voltage. Suppose if it is 100 voltage, the rated voltage is 100 voltage, the arc voltage will be equal to 3 volts, right? Next one, arc interruption. This is one of important topic in your module 4. So there are two types of arc interruptions we have. One is high resistance interruption, current 0 interruption. How we are going to interrupt the arc, that is the main aim is here. So in that we have two methods. One is resistance is increase, high resistance interruption, and otherwise making current to equal to 0, that is called as a current 0 interruption. The first method, is high resistance interruption. So high resistance interruption means increasing the resistance. So you have to remember, increasing the resistance, and automatically the current will be reduced, then arc will be maintained to certain level. So in high resistance interruption method, the resistance is increased so as to reduce the current to a value insufficient to maintain the arc. So reduce the current, then arc will be maintained. So arc resistance can be increased by cooling, lengthening, constraining, and splitting the arc. So we can also increase arc resistance by cooling of the circuit breaker, lengthening of the arc, constraining of the arc, and splitting of the arc. So we can be doing like this, so we can interrupt the arc in the circuit breaker. And we will move to the second type, current 0 interruption. So current 0 interruption applicable only AC circuit breaker. So we cannot use for DC circuit breaker, but high resistance interruption, so high resistance method we can use for DC also. So in case of AC supply, the current wave passes through 0 point. All current sinusoidal waveform will passes to 0 100 times per second. Then frequency value will be 50. So here the current value will passes to origin, that is called as a 0. Then we can call it as a AC current. So in future AC is utilized for arc interruption. So this method, current 0 interruption, is used for arc interruption. So in only AC circuit breakers. So next one, current zero interruption again classified into two types. One is recovery rate theory, another one is energy balance theory. So in recovery rate theory, the arc is a column of ionized gases. So arc will have some ionized gases. So in continuously it will produce. So to extinguish the arc, the electrons and ions are to be removed. So to extinguish the arc, so we have to remove the ions and electrons in the arc. So it will be implemented by recovery rate theory. So how? So the gap immediately after current reaches a natural zero. So the gap of the contacts so should be uh, immediately should happen. Okay. So next one, energy balance theory. So the space between the contacts, between fixed contact and moving contact, some ionized gases immediately after current zero, and hence it has a finite post zero resistance. So energy balance theory means, so whenever contacts are open, so ionized gases immediately we have to make it as a zero. So then the energy will be balanced, then arc we can interrupt. So these are the way graphs. So we can see before arc extinguished and arc does not extinguish. Extinguish. So in that arc extinguish, so dielectric strength of the voltage and restaking voltage magnitudes if you observe, the dielectric strength of the voltage will be more than the restaking voltage. So when arc extinguishes, so arc does not extinguish, so restaking voltage magnitude is more than the dielectric strength of the magnitude. So arc does not extinguish, there is no point of dielectric strength. So the magnitude, so we can see the difference. So when arc extinguish, when arc does not extinguish, so there is no arc there is no arc, that means arc does not extinguish inside the circuit breaker, then the dielectric strength will be less. When the arc is extinguished, suppose fault occurs, arc extinguished, so we need to increase the strength of the medium. So that's what the dielectric strength of the medium is more. Okay. So this is about arc interruption and arc voltage. So next video, so we will see about restaking voltage and recovery voltage, current tubing, interruption of capacitive current. Okay. So in this video we have discussed arc voltage. Arc voltage means, what is meant by arc voltage? The voltage drop across the arc is called as a arc voltage. Okay. So arc interruption means, so we need to eliminate the arc. So by using two methods, high resistance method, current zero interruption method. Okay. So if you observe the graph, so we can come to know when the arc extinguished, when the arc does not extinguish, the dielectric strength and restaking voltage magnitude we can observe here. So in next video we will see about these topics. Okay. Thank you everyone.